One particular series that we are interested in is what is called a geometric series. And a geometric series is, remember, a series is basically a summation of numbers. So a geometric series is a summation of numbers, but what happens from one number to the next number is you're multiplying by the same number every single time. So notice here, in order to get to 1 to 1/2, you're multiplying by 1/2. Same thing to get from 1/2 to 1/4. And same thing from here to here. So that number that you're multiplying by every single time is called your common ratio. And in this problem, it is exactly 1/2. So if we look at these particular series, let's see if we can try to find these common ratio. So here, what number am I multiplying to get from 6 to 4 and then 4 to 8/3, etc.? Your common ratio in this problem is actually 2/3. If you do 6 times 2/3, it's 4. If you do 4 times 2/3, you get 8/3. Now, sometimes if it's not so easy to tell what that common ratio is, you can work backwards. So instead of trying to figure out what number you multiply 6 by to get to 4, you can go backwards and just divide. So 4 divided by 6 is your 2/3. So you can figure it out that way as well. Some of the problems will be much simpler, like number 2. Notice that you're multiplying by 2 every single time, so your common ratio here is 2. Here, number 3, all you're doing is multiplying by 1 every single time, so your common ratio here is 1. And then notice number 4. First of all, you should notice that the signs are changing from negative to positive, so that means your common ratio has to be a negative number. And then notice you're multiplying by 1/2. So first thing we want to be able to do is find that common ratio. The next thing we want to be able to do with the series is determine whether the series converges or diverges. So what that means is if I add up these numbers infinitely, is there a sum to that infinite series? If there is a sum, we say it converges. If there is no sum, we say it diverges. Now, if you think about it logically, the only way that a sum could conceivably add up to a value is if the numbers are actually getting smaller. Like in number 2, if the numbers are getting bigger and bigger, every time that you add another number, the sum is just getting bigger and bigger. So I can tell that this is going to diverge. There is no sum to this infinite series. We're adding up numbers infinitely. So the only way a geometric series can converge is if that common ratio is less than 1, and it's actually when it's the absolute value of r is less than 1. So using that idea, if I look back to the 4 problems that we did, notice that this, based on that, this is going to converge because your r is less than 1. Number 3 is going to diverge because this is exactly 1. It's got to be less than 1. So if you think about it logically, all you're doing is adding 7 every single time. That sum is just getting bigger and bigger. So that will never get to a sum. Number 4, the absolute value of r is less than 1. So we are going to say this converges. Now, the next thing is now we know whether there's a sum and when there isn't a sum. Now we want to figure out, okay, what is that sum? So this is something from pre-calc last year. You may or may not remember it. But for a geometric series, and notice here, instead of writing out all the terms, we're using the sigma notation to represent that series. And this is how geometric series is written. You have the first term, and basically you're multiplying by r every single time. So the sum of a geometric series is a, which is the very first term in your series, divided by 1 minus r. And you would only have a sum if it actually converged. So for number 1, if I wanted to know what is the sum of this series, if I add up these numbers infinitely, your sum is going to be a, which is 6, over 1 minus r. And we can clean this up a little bit. This is really 6 over 1/3, which is actually 18. So this series, if you add up the numbers infinitely, is actually 18. The only other series that converges here that we said was number 4. So the sum of this geometric series would be a over 1 minus r. In this case, r is negative 1/2. And let's clean this up. So I have 10 divided by 11 halves. So if I simplify this, this is actually going to be 20 over 11. That's the sum of this infinite series. So now let's go ahead and look at these problems on the bottom. I want to determine whether the following series converge or diverge. If it converges, I want you to find the sum. So notice here, your R value is 1/2. So notice all of these problems, instead of writing it, listing out the terms, I'm writing it in sigma notation. So if you want to write it out, you can. Really, the first term here is 1/2 to the 4th, right? We're starting at 4. And then the sigma means you're adding, so your next term is 1/2 to the 5th plus 1/2 to the 6th, etc., all the way to infinity. But you actually don't have to write it out like this to figure out what that R value is. You're multiplying by R every single time. That's what a geometric series is. So whatever is being raised to the nth power is always going to be your R. So I don't necessarily need to write it out to figure out what that common ratio is. So my R is 1/2, and based on what we learned, I know that this series is going to converge. So if it converges, I do want you to find the sum. So the sum would be A, which is the first term in this series. The first term is what happens when I plug in 4 for n. It's 1/2 to the 4th, which is actually 1/16. A over 1 minus R, and simplifies to 1/8. So letter B. Notice here your R is also 1/2, but notice, so we know that it's going to converge, so we need the sum. But notice here, the series is starting at 0, so your first term is 1/2 to the 0, which is 1. So the sum in this case would be 1 over A over 1 minus R, and this is 2. Okay, number 3, letter C. This is just a number. If you want to do this, you can rewrite it like this. So that 3 will get multiplied to everything else in the problem. Sorry, it's 1/2. The 2's on the bottom. So notice it's only the 2 on the bottom that's being raised to the nth power. So your R here is also 1/2. But then what's your first term? We're starting at n equals 0, so your first term is just that 3. So because R is less than 1, I know it converges. So we can find that sum. So that would be A over 1 minus R, which is 6. Okay, letter D. Notice the whole thing is raised to the nth power, so your R is 3/2. This is not less than 1, so this diverges. So there's no sum to this series. If it diverges, you're done. Letter E. Notice that only the 2 is being raised to the nth power, so your R is 2. Is not less than 1, so this also diverges. So that means there is no sum. Some of these problems, you may want to use properties of exponents a little bit to simplify it first. Like this one here, I'm going to rewrite this. This 3 to the n plus 1, really I can break it up like this. Properties of exponents say I can break that up. So think about what is being raised to the nth power, right? As the n changes, that's the only thing that's changing, so that's what you're multiplying every single time by. So really, you are multiplying by 3/5 every single time. That number is less than 1, so that means this series converges, which means there is a sum, and the sum of this series would be A. The first term is, what do I get when I plug in 0 for n? It ends up being 3. A over 1 minus R. This is 15/2. Same idea. So notice here, the -2 on the top and the 3 on the bottom are both being raised to the nth power. So your R here is -2/3. Absolute value of that is less than 1, so we know it converges. So your sum is going to be A. So A would be, what do I get when I plug in 1 for n here? It's actually -2/3. That's my first term. All over 1 minus R. And this ends up being -2/5. R here is -2. There is no sum, so we say it diverges. Here, I'm going to split this up. Let's do this. Pull that 3 out. And then you are subtracting, so we can go ahead and split this up into 2 separate pieces. So let's do each piece separately. This piece, I know your R is 1/2, so it converges. this piece, your r is 2/3. So each sigma has its own sum. So to find the final sum, I can just go ahead and subtract them together, which is the operation in the middle. So your a in the first sigma, if I plug in 1, is 3/2. A over 1 minus r minus this second one here is a is 2/3 over 1 minus r. If you clean all this up, this ends up getting all the way to 1. Okay, the last two problems, not written in sigma notation, but we still want to pull out the same information. Notice here your r is 3/4. Really, if you can't figure out what you're multiplying 8 by to get to 6, just work backwards. 6 divided by 8 is 3/4. So that means that you do have a sum because it's less than 1. My first term is 8, so your sum is a over 1 minus r, which is going to give me 32. And the last one, your r is -1/2. Notice the signs are changing. So I do have a sum, which is going to be a over 1 minus a -1/2, which is going to give me 8/3.